Hello everyone, welcome to the first video in my channel. In this video, I'm going to be covering some of the important foundations in organic chemistry. So this has to do with understanding the way that atoms bond to each other, how electrons are shared or transferred, and how these interactions determine molecular structure and reactivity. And so I plan to go step by step, starting with atomic bonding, then to resonance and formal charge, and then finishing it off with hybridization. So let's start off with the idea of bonding itself. So atoms tend to form bonds to achieve stable electron configurations, usually by reaching a full valence shell, and this rule is called the octet rule. And so the two primary types of bonds that we're going to focus on are ionic and covalent bonds. So ionic bonds tend to form when electrons are transferred from one atom to another, and this creates oppositely charged ions, one being positive and one being negative. So a very common example of this would be sodium and chlorine. And so if you look at the uncharged atoms, the uncharged chlorine and uncharged sodium, uncharged chlorine will have 7 valence electrons. And uncharged sodium, neutral sodium, sodium in its natural state would have 1 valence electron. And so first of all, the way to denote how many valence electrons an element has is by assigning the numbers to this table to each group. So groups 1 and 2, they have 1 and 2 respectively, valence electrons. And then here you go over to groups 12 through 18, numbers corresponding to their valence shell electrons 3, 4, 5, 6, 7, and 8. And helium isn't included in this. And so this is a very simple example of ionic bonding. So these two are neutral, and sodium will tend to donate its electron to chlorine, and the result would be sodium being positively charged now, and chlorine being negatively charged. And if you look at the number of valence electrons, chlorine now has 8. And this is an example of ionic bonding. So covalent bonding, on the other hand, occurs when atoms share electrons with each other. And an example of this would be methane. So methane, CH4, a carbon with bonded to 4 hydrogens. And so if we were to draw out the structure for this compound, it would look something like this. Right now, we're not going to be worrying about molecular geometry or anything like that. So essentially, what covalent bonding is the sharing of electrons between two atoms. And what this single bond between the carbon and hydrogen is saying 1 electron from carbon and 1 electron from hydrogen are making this bond between these two atoms, and now both of those electrons apply to those atoms in order to fill their octet. So by having 4 of these, essentially you have 8 electrons on carbon completing its octet, and hydrogen is happy with 2. And so covalent bonding is dominant in organic chemistry because it's pretty much the framework of all carbon-based molecules, which is what organic chemistry focuses a lot of its time on. So now that we know atoms share or transfer electrons, let's look at how we represent that on paper through Lewis structures. So the steps to drawing a Lewis structure start off with counting the number of valence electrons, for all atoms involved in the compound. The second step, draw a skeletal structure. And in the skeletal structure, you're going to want to draw it connecting the atoms around it with single bonds. So next, you're going to want to complete the octet around outer atoms first. So you want to start with the outer atoms first because oftentimes that will make it easier to finish off the structure. And next, you're going to want to place any remaining electrons on the central atom. So let's do a little practice now that we know this. So let's say you're given the compound NH3, ammonia. How would you draw the Lewis structure for this compound? Take some time to do this and remember to follow these rules. So if you were to count the valence electrons, you would see that hydrogen has 1 and you have 3 hydrogens, so that's 3. And then you have 1 nitrogen and nitrogen has 5, so that's 5 more. And so you have 8 valence electrons in total. So we draw the central atom, which would be nitrogen, then single bonds connected to the other atoms, in this case would be hydrogen, and you have 3 hydrogens. And now if you were to count the number of electrons taken through these bonds, you'd see you have 2, 4, and 6. And the reason, remember, is because you're taking 1 electron from the hydrogen and 1 electron from the nitrogen, and you're forming that single bond. And that's how covalent bond works. And so you have 2, 4, and 6, and you have 2 left. All the hydrogens octets are full, and we could see that we have 2 left, and so you would want to place them on the central atom, nitrogen. And there you go, you have the Lewis structure for ammonia. So once we have this, we're going to want to calculate what's called formal charge. And so the formula for calculating formal charge would be the number of valence electrons minus non-bonding electrons minus 1/2 bonding electrons. So in this formula, the valence electrons corresponds to the number of valence electrons that the compound you're trying to calculate has. In this case, nitrogen has 5. The non-bonding electrons are electrons that are on that compound that are only bonded to that compound. So in this case, nitrogen has 2. And then the bonding electrons are the amount of electrons that are used in the bonding between the atoms. So in this case, you have 3 single bonds, and like we said before, this is just 2 electrons forming the bond. So in total, you would have 2, 4, 6. And so the answer you would get for this would be 0. So nitrogen has a formal charge of 0 in ammonia. So here, find the Lewis structure for H2O and calculate the formal charge of the oxygen. So go ahead and pause the video and take a little bit to solve this problem. So with H2O, you have 2 hydrogens and 1 oxygen. So for the 2 hydrogens in total, that's 2 valence electrons, and for oxygen, 6. So the total number of valence electrons is 8. So with that in mind, we have the oxygen. Draw the single bonds to the hydrogens. And here we have 2 and 4. We have 4 electrons left. We're going to go ahead and place those on oxygen. So in total, we have 8. And now to calculate the formal charge of oxygen, we have the number of valence electrons that oxygen has, which is 6, minus the non-bonding electrons, which is 4, minus 1/2 the bonding electrons, which in this case, it has 4 bonding electrons, 2 from this hydrogen, 2 from this hydrogen. And what we get, 6 minus 4 minus 2 is equal to 0. So in water, the formal charge of oxygen is 0.